So, we studied one of the very important service of the data link layer, the framing, or you can say the function of the DLL. Another service of the DLL that it supports is the mode of communication, that is the half duplex and the full duplex mode of communication. And you know what is a half duplex and a full duplex mode of communication. In half duplex, what happens? The transmission is possible in both the direction, but one at a time. If this is T1 and this is T2, then T1 is never equal to T2. That is what is half duplex transmission. In a full duplex transmission, your transmission takes place in both the directions and at the same time, T1 and T2, and if it is a full duplex, then T1 is equal to T2. That is what is the specification or the difference between the half duplex and the full duplex transmission. Now, one of the major function or the service that is provided by the data link layer is the flow control. Flow control meaning the control of the flow of the data such that the sender and the receiver, both of them are controlled for their speed as well as the amount of data. If sender and receiver are communicating and they have two parameters you consider, one is the speed of communication and the size of the data that is being communicated, then both of these are maintained or both of these are controlled by this flow control mechanism, so that neither the sender nor the receiver they lose their capability or they lose the data even. That is what is flow control. Let us say the sender is a faster sender and it transmits the data to the receiver. The receiver is a slow receiver, or the receiver has a less buffer size. Either the buffer is small or the speed is less. In both the conditions, when the sender transmits the data, the receiver won't be able to handle the data or receive the data for processing. In that case, what will happen? The sender will go on sending the data and some of the packets or some of the data will be dropped. So, we cannot have an efficient communication if proper flow control is not maintained by the receiver as well as the sender. And this flow control mechanism requires the half duplex and the full duplex communication. So, to maintain the flow control or to obtain the control of flow between the sender and the receiver, there are certain protocols are used. They are called the flow control protocols. One of the very important flow control protocol is stop and wait protocol, and another is sliding window protocol. When stop and window supports the half duplex mode of communication, the sliding window supports both half duplex as well as full duplex. So, we will see first the stop and wait protocol. The name itself explains what the kind of protocol is. What happens in this protocol? Let us say we have a sender here, we have a receiver. The sender, because it is a data link layer, the packet or the data chunks are called the frames. Now, let us say the sender sends the first frame to the receiver, frame 0. When it sends the frame 0, the receiver receives it and processes the frame, and once it is ready to accept the next frame, it sends an acknowledgement to the sender. The acknowledgement indicates that I have received your previous frame and now I am expecting the next frame, the number is 1. Now, when the sender receives the acknowledgement 1, it understands that my receiver has received the previous frame. So, what it does? It sends the frame which is expected by the receiver, that is frame 1. And the same thing happens to the receiver. Now, again the receiver sends the acknowledgement for frame 0, F0. Sorry, this is acknowledgement 0, sorry, ACK 0. And now the sender again sends the frame 0. So, what happens in this protocol is the receiver holds the sender for certain time being till it is done with the processing of the data that is being received, and the receiver is waiting to get the acknowledgement from the receiver. Unless otherwise it receives the acknowledgement, it cannot send the frame. That is why we say this is a stop and wait protocol between the sender and the receiver to control the flow of the data. Now, there is a question, why I say this is F0, F1, F0 and F1 again, why? Why not F0, F1, F2 up to Fn? Why the difference between, why the naming of the frames are such 0 and 1? Can anybody answer this question? One bit of?
One bit of data can be used to say which frame is moving. Maybe ACK 0 would mean just to send the next frame. Like if the previous one was ACK 1, ACK 0 after that would mean the next frame and not the first initial frame.
Yeah, somehow it is correct. Let us say I am saying F0, F1, F2, F3 up to Fn. There are two reasons for this, right. The first reason is my frames are being numbered from 0 to n, and what are these numbers? They are the address bits for the frames, correct. Now, how much space the sender can afford to give an address bit to be incorporated or encapsulated in a frame? If you go for the digital version, binary version of this, if I use a 0 and a 1, I use a single bit. If I use 2, 3 up to n, accordingly I have to use that many number of bits. And if I use that many number of bits, obviously my size of the frame will be again increased. Agree? So, what happens here? I am reducing the numbering or addressing bit for naming or addressing a particular frame, so that the frame size will not be more and the contents of the frame will be the actual data than the all these address fields or the control overheads. Now, how it is possible? It is only possible because the protocol name is stop and wait. Unless F0 is processed, the next frame is not allowed to send. So, in that case I can give F0 and F1. If it is allowed to send 2, 3 frames, can I give the F0, F1 and F0 again? Not possible. The reason is 2 frames will be having the same numbers. Now, because it is a stop and wait protocol, only one frame is sent and that frame is processed, then the next frame is sent. So, you can make this kind of addressing to the bits for the frames, only F0 and F1 alternatively, right. So, this is what is your stop and wait protocol, and we will see the utilization of stop and wait protocol, how much, what is the efficiency of this protocol and what is the utilization factor for this protocol, we will see them later. Let us understand the protocol first. So, F0 and F1, and now you send the acknowledgement 0 and acknowledgement 1, and the receiver is stopping and holding the sender to transmit the next frame. So, this supports your which kind of communication? The half duplex communication, right. Now, just imagine the channel or the bandwidth that is being used for transmission. If it is a frame, that is fine. If it is 1 Mbps bandwidth, I am sending a frame of some size, considerable size, then fine, the bandwidth is utilized. Now, same 1 Mbps bandwidth is utilized for sending an acknowledgement. Can you imagine what an acknowledgement signal can be? It is just a 1 by 2 byte data. Just to send and control signal acknowledging the packet has been received. So, your whole of the bandwidth is now underutilized when you send the acknowledgement, correct. So, this reduces the utilization or efficiency of the whole communication channel. How much it is reducing, that we will see later. So, this is what is the drawback of your percentage of efficiency. Efficiency is reduced and the channel is underutilized in case of this half duplex mode of communication or this stop and wait protocol. To avoid this, there is an improvement upon this protocol called a sliding window protocol. What this protocol does, instead of sending one frame at a time and waiting for the response to come back from the receiver, the sender is allowed to send multiple number of frames depending on the capability of the receiver. Let us say the receiver is capable to process 100 number of frames. In case of your half duplex, in case of your stop and wait, what you are doing? You are sending one frame at a time, waiting for the receiver to send back the acknowledgement. When the receiver is capable to process 100 frames, you are sending only one frame, right? To avoid this, the sender and the receiver, they first try to understand, or there is a mutual agreement between these two to understand how much data that can be handled by the receiver at any time, or how much data the sender can transmit at any time, depending on their capability, speed and the size of the buffer, everything. Now, let us say the sender and the receiver, they say that the sender says and the receiver says that they can work upon 8 number of frames at any time. That means the sender is able to send 8 frames at a time, the receiver is able to process 8 frames at a time. Let us say n is equal to 8, and that 8 is called the window size of the flow. So, now this is agreed between the sender and the receiver that they can work on 8 frames at a time, meaning the sender can send 8 frames at a time without waiting for the acknowledgement from the receiver. In the stop and wait, it was sending one frame, waiting for the acknowledgement, then sending the next one. But now this protocol says the sender can send n number of, or the window size number of frames without waiting for the receiver an acknowledgement, right. So, how this protocol works? The sliding window protocol, how this protocol works, we will see. Let us say this is the sender side and here is your receiver side. F0, F1, F2, F3, F4, F5, F6, F7, F8, or I can say again F0, F1, F2. Now, you understand why I am saying this F0 again after 7. The size of the window is 8. So, here also at the receiver side I have same F0, F1, F2, F3, F4. This is the buffer for 7 number of frames, 8 number of frames, F6, F7, F0 again. So, now my window is F0 to F7 having 8 number of frames at a time. When the communication starts, the sender, let us say the sender starts transmitting 3 number of frames at a time, F0, F1 and F2. 3 frames are being transmitted from the sender. Now, when 3 frames are transmitted from the sender, the window is shrink to this number. These many frames has been already transmitted, correct? F0, F1 and F2 has been transmitted. So, the window is now shrink to this. Now, these 3 are being received by the receiver. So, now F0, F1 and F2, they are being received by the receiver. Now, after getting these 3, what the receiver does, it expands its window to next 3 frames, F0, F1 and F2. Now, again 1, 2, 3, 4, 5, 6, 7, 8. So, the window size remains intact and the window is now expanded in this direction. So, here the window is shrinked at the sender side and the window is expanded in the receiver side to the same number, the size of the window does not change. Now, after receiving these 3 frames and expanding the window for another 8 number of frames, the receiver now sends back the acknowledgement. Acknowledgement for which frame? F3, saying I have received up to frame 2, now I am ready to receive the frame up to F3. In the meantime, the sender, because he is allowed to send up to F7 number of frames, he did not wait for the acknowledgement and he sent, let us say, another 2 sets of frames, F3, F4, F5, F6, F7, all this. So, what it does, without waiting for this acknowledgement, and the window was here. Before getting this acknowledgement, now the sender has transmitted 2 more frames, F3 and F4. Do you understand? Because the sender has the principle, by principle sender knows that I can send any number of frames up to F7 without waiting for the acknowledgement, because I know that the receiver is capable of handling 8 frames at a time up to F7. So, he transmitted F3 and F4, and in the meantime after sending this F3 and F4, it receives the acknowledgement F3. So, when it receives the acknowledgement F3, that means it ensures or it is confirmed that the receiver has received 3 number of frames, and when it has received 3 frames, it must have expanded its window to another 3 frames. So, what this does, it also increases its window to 3 frames more after receiving the acknowledgement only. This is F2. So, now the window again is consists of 8 frames, 1, 2, 3, 4, 5, 6, 7, 8, right, and virtually, but actually what it has done, it has transmitted these many, correct. What is the meaning of this expansion is that it is understood that the receiver has received 3 frames and it has expanded the window to another 3 more frames and it ends with F2. So, the sender is now only capable to send up to F2, not beyond that, right. So, what it does, after sending F3 and F4, it still has the option up to 1, 2, 3, 4, 5, 6 more frames it can send. And when these 2 are received, what the receiver does, it receives the frame F3 and F4, now F6, F7, F0, F1, 2, and this continues. So, once it receives F4, the window is now expanded for another 2 more windows, that means up to F4, 2 more frames, correct. That means the receiver says that now I am ready to receive up to another 8 number of frames starting from F5. I have received up to F4, starting from F0 to F4, that is over, I have processed. Now I am ready with another set of window having 8 number of frames, F5 to F4 again, and it sends back the acknowledgement of acknowledgement 5. This is actually acknowledgement ACK3, not F3, right. So, it sends ACK5. When it sends the ACK5, let us say in between the sender has not sent any frame, so it is sitting idle, and what it does, after getting this acknowledgement, it again expands its frame starting from F5 to F4 again. So, it has now again a window of 8 number of frames, right. Now, let us say now the sender sends all the 8 frames now starting from F5 to F4, all 8 number of frames it can send, because the window size is 8 and the receiver has expanded the window and it has sent an acknowledgement that I have received up to F4 and next acknowledgement starts from F5. So, when it sends all the 8 number of frames to the receiver, so where the frame will be now, the window of the sender side will be, now the window has been shrinked to the last value, it has been totally shrinked. because it has transmitted all 8 number of frames. Can the sender send any more frames now if it wants to? No. When can it send? After getting the acknowledgement from the receiver. So, when it sends all 8 frames, it has exceeded its capability. That means sending 8 frames maximum at a time. So, it has sent all the frames and it has been shrink. The whole of the window is shrink to 0 value, and now only the receiver can send an acknowledgement. If it receives up to F4, if the receiver receives up to F4, then the next window will start with F5. This will continue again 8 number of windows. Only when these 8, the window of 8 frames will be expanded and this fellow sends an acknowledgement of 5, then only the sender can send its window and send it. That means the new window will be now set with F5, F6 and so on and so forth. So, what is the strength of this protocol? Your channel or the network resources are better utilized. Instead of sending one frame at a time, you are sending multiple number of frames, utilizing the channel capacity in a better way. And the sender has the provision of sending as many as number, up to the window size without waiting for the acknowledgement from the receiver side. Once the acknowledgement is transmitted, it only has the capability to expand the window and do the same procedure, repeat the procedure again. That is what is your sliding window protocol. The name explains that if one way the window slides to the right, it shrinks, another way it expands. So, the window size or the window shrinks and expands at the sender and the receiver side depending on the transmission and acknowledging of the packet. So, this is called a sliding window protocol. Now, you tell me whether this kind of communication is a half duplex communication or a full duplex communication. Is this half duplex or this is full duplex? Who says this is half duplex? Raise your hands. This is full duplex. So, this is none. No transmission at all. The communication is in between two directions, right? But is the communication at the same time? So, this is what kind of communication then? Now, it is your half duplex, right? So, though it is a protocol that supports the multiple transmission, multiple frame transmission, but again the problem with this is while sending the acknowledgement, you are underutilizing the resource, right? So, how this could be solved? Let us say both the sender and the receiver, they have the data, not exactly sender and receiver, I will say rather two nodes A and B. Let us say both of them have got the data to transmit. Possible? So, now A and B both are transmitting the data. This has got the data and this has also got the data to transmit. And they, along with the data, they also need to acknowledge. If they do not acknowledge, again it is a non-reliable communication and this has to be acknowledged at any cost. So, now when this sliding window protocol, when the window will be decided by the sender and the receiver side and the frames will be transmitted, along with the frames a control message will be also transmitted, that is called the acknowledgement. That means your data is piggybacked with the acknowledgement, right. So, let us take an example. Let us say your frame is, okay, let me do it this way. Let us say you have some window size is 4, let us say smaller window size or 5 I can say, here also the same, and both are having the data. Now, this fellow is sending 2 frames, let us say F0 and F1, F0 and F1. So, it is now shrinked here. Now, the window is here, this says data has been already transmitted, right. At this point of time, B receives 2 frames, these 2. So, it expands to 2 more frames now. This is expanded and this is shrinked now. This has been received. So, what it is supposed to transmit? The acknowledgement for 3. Acknowledgement for 3. At the same time, it too has got the data to transmit. So, now another window will be maintained by this node, let us say B, this is A node and this is B node. And this has got again the same 5 of window, and now let us say this is to transmit 3 frames F0, F1 and F2. So, now the acknowledgement and the frame both are transmitted. This is this is the window. So, now this is the data to be transmitted by the node B along with the acknowledgement for this data that it has received. That means, your acknowledgement is transmitted along with the data and both are piggybacked. So, what you do now? Your data as well as acknowledgement are transmitted. This end also your data and the acknowledgement for these frames will be transmitted. So, now tell me, does it support the full duplex mode of transmission? Because both the side data and the acknowledgement both are being transmitted at the same channel. So, we say it is a full duplex mode of transmission, provided it has the provision of piggybacking the data along with the acknowledgement. So, in that case what happens? You have one buffer window. This buffer window is for receiving the nodes, this is for receiving and this is for the sending of the data. Similarly, at the sender side, I mean the other side also, this will have 2 windows, one window for receiving the data and another window for sending the data, correct. So, now your full duplex mode is possible by this sliding window protocol, multiple frames in a window, and the window will decide, the size of the window will decide the capability or the flow of the transmission, and accordingly the sender as well as the receiver, they will transmit the data and your channel will be utilized. This is what is your flow control mechanism for this data link layer, which supports both this stop and wait, which is a very low utilized channel utilized protocol, and a sliding window protocol, which is a better channel utilization protocol.